And this is just a quick review of the last two things we did on the topic of what's called conic sections. These are the graphs that you get from the different shapes you get from graphing what we call quadratic equations that have exponents of two of them. And we had done already two. One thing was called the parabola, which was a U-shaped, either facing up or facing down. And one was a circle, and everybody knows, of course, what a circle looks like. So we had those two that we had covered previously. And then we talked about two others, something called an ellipse and something called a hyperbola. And we're going to recognize that this one, number one, is the ellipse because it has an x squared and a y squared. But notice the numbers in front of the x squared and the y squared are not just plain one. They're different coefficients, and there's a plus in between them. The one underneath it happens to be a hyperbola. It's a hyperbola because there is an x squared and a y squared term, but between the two terms, there is a minus. When there's a minus between the x squared and the y squared term, we get hyperbola. So looking at this first one, we're saying that this one is an ellipse, which an ellipse looks like an oval. And the first thing we have to do with this is put it in standard format. Number two happens to already be in standard format, which is x squared over a squared plus y squared over b squared equals 1. This is the standard format of an equation for an ellipse. So when it doesn't equal 1, the first thing you have to do is divide by the number that's on the other side of the equation. By the way, you have to if the x squareds and the y squareds are on different sides of the equation, you have to bring them to the same side of the equation. So that always have the x squared and the y squared on one side and the number on the other side. So we're going to divide everything by 36 so that we can put this in standard form. Now here, there's a 4 on top and a 36 on the bottom. So we can cancel out the 4. Remember, you always cancel out the lower number. And what you're left with in the bottom is 9. Over here in the second one, which gives you x squared over 9. Over here, I have a 9 in the numerator and a 36 in the denominator. So I can cancel out the 9, that's a lower one, and divide the 9 into the 36 gives me 4. So this gives me y squared over 4 equals 1. Before we graph the ellipse or the hyperbola, we must put them in standard format. Again, we're only dealing with these two special cases where of the ellipse and the hyperbola where they center on the origin. And after we put it in standard form, this will give me that my a squared is the 9, which means a could either be plus or minus 3. The a squared is always a number under the x squared. The b squared is 4, which is giving me that the b could be either plus or minus 2. Okay, so remember the a's are the x-intercepts, the b's are the y-intercepts. So this ellipse will cross the x-axis at 3 and at -3, and the y-axis will cross at 2 and -2. So you should have gotten something that looks like this. An oval shape, flattened So it's longer along the x-axis and shorter along the y-axis. It's basically as if you took a circle and squashed it. Just, this is all you'd have to do, just as a matter of information. The ellipse has what we call two axes. One is a major axis, which is a longer, cuts it the longer way. And the other one, the smaller one, is called the minor axis. And in this case, the major axis is along the x-axis because that's the longer one. And the minor one is along the y-axis. If I ask you how long is the major axis, you go 1, 2, 3, 4, 5, 6. Notice it goes from the center 3 in each direction. So the major axis is 6 units long, and the minor axis is just 4 units long. It's always double whatever the A and the B are, because these numbers are from the origin to the edge, and the major axis, when I ask for the major axis, I'm going from edge to edge. Okay. So that takes care of number 1. Let's look at number 2. Number 2 is what we call a hyperbola. Let's put this over here so we know this belongs over there. So we're now talking about something called a hyperbola. Not only is the name strange, the whole shape of it is strange. And that's because there is a minus in between them. And because of that, we don't have 2 sets of intercepts. We only have 1 set. The one that's positive, which in this case is y squared, is going to give us the y-intercepts, and the x's will not give us any x-intercepts, because if I tried to get the x, I'd get a square root of a negative number, and that would not work. So in this case, when it starts y squared minus the x squared, the number underneath the y squared is 25. That's the b. Is either plus or minus 5, is the y-intercepts. There are no x-intercepts. So when you have hyperbola, you're going to have 2 U-shapes facing back to back, sometimes sideways, sometimes up and down. Basically, the shape of the hyperbola put all these in. Line up the ones that are garbage on the floor, so I know I don't use them anymore. I'm going to go 5. I'm going to do 5 up. 1, 2, 3, 4, 5. As one y-intercept, and 1, 2, 3, 4, 5 as the other y-intercept. And then I'll make these 2 mirror image U's. Basically looks like this and like this. As again, it's 2 separate. The graph consists of 2 separate parts that don't connect. This is each part, but the graph of the hyperbola is both. It's not exactly, it's sort of, if you think of a parabola as 1 U, this is 2 U's, but again, they're not exactly the same shape. And sometimes a U is very open, and sometimes you have a U that's narrower. And there are ways of figuring out exactly whether you should make a wide open U or just a narrow U But that's, again, beyond the scope of what we have to do in this course. We just have to be able to look at it and do a quick sketch of the example. And of course, since you're going to have, your test is going to be multiple choice, that means that you're going to have to pick out the correct ones. And the thing that you're always going to be looking for is to make sure you're getting the right intercepts. Is it crossing the X and the Y axis at the same right places? And you also have to recognize, do you have an ellipse or do you have a hyperbola? Again, next time we'll talk about, maybe we'll do a review of the circle and the parabola as well. Those you have to know a little bit more about. You have to be able to find the vertex of the parabola. I still left the equation over there, as well as its X and Y intercepts. And the circle, you have to be able to put it in standard form so you can find its center and its radius. Those are things we had done last class, but the previous classes before that. Those four shapes, this is just, I want to just review this right now. The four shapes on, can I erase this now?
Yes, you can erase it.
Okay. So let's just, now that we talked about them, let's just review and look at, see if we can just take a quick, if I look at an equation, can I tell if I'm going to have width in a circle, ellipse, what are we going to have? So the four types of conic sections, as we said, are number one, the parabola. Number two, the circle. Number three, the ellipse. And number four, the hyperbola. And these are the four types of shapes you can get, the four types of graphs you can get from graphing an equation that has an x squared and a y squared or one. Sometimes it just has one, just the x squared and not the y squared, just the y squared and not the x squared. But most of them, and that would be a parabola, and that's the shape of a parabola is U-shaped. Sometimes it opens up, sometimes it opens down, and it has an equation where usually it looks like something like this: y equals ax squared plus bx plus c, where we have an x squared, but there is no y squared. Only one of the variables is squared. Again, you might have other things. When we're looking at this, we're looking specifically at the variables that have an exponent of 2. The other things are not so important, but what is happening to the variables with the exponent of 2? Again, we mentioned that if your A is positive, it opens up because you have a smile. And if your A is negative, it opens down because you've got a frown. And again, you can find the vertex. Actually, I still have the equation on the board, the formula on the board. The circle, of course, we know what it looks like. And the standard equation of a circle usually is going to have x squared plus a y squared in it. It's going to have a bunch of other things. But basically, the important things is there's going to be 1x squared plus 1y squared. And we even talked about how we would find what the center of that circle is and what the radius is. Again, we're not going to review this, but we would recognize it by looking that they're both an x squared and a y squared term in it. And and remember, you always have the x squared and the y squared, always have the b on the same side of the equation. And they're both going to have coefficients of 1. They're just going to be 1x squared and 1y squared. If there is, let's say, a 5x squared plus a 5y squared, then the first thing you do would be divide everything by 5. So again, both of their coefficients, both of the numbers in front of the x squared and the y squared is 1. The next type of thing, this is what we were just talking about, is an ellipse. Sometimes it's squashed horizontally, sometimes it's squashed vertically. So sometimes you have an ellipse that runs the other way. The standard form of an equation, but the equation of a ellipse you'll recognize because you'll have an x squared over a number plus a y squared over a number. It's going to equal something. Notice it has an x squared plus a y squared, but there are numbers underneath the x squared and the y squared, the a and the b, and they're different numbers. They're not the same number. Sometimes also it's written like you might have a number in front of the x squared plus a number of the y squared. That also will be an ellipse. As long as there's an x squared plus a y squared, but the coefficients are not just plain 1. They have different coefficients. The number in front of the x squared or underneath x squared, sometimes the coefficient is underneath, which means that the coefficient here really is 1 over a squared, because that's what the x squared is being multiplied by. But it's a different number. The x squared is being multiplied is different from what the y squared is being multiplied. The hyperbola is this two back-to-back facing u's, and the standard equation for hyperbola will be x squared over a squared minus y squared over b squared. Well, then really, this is equal to 1. And this way, it'll be the y squared over the b squared minus the x squared over the a squared equals 1. And again, you'll recognize the equation for a hyperbola because between the x squared term and the y squared term, again, they're both on the same side of the equation. There's a minus in between them. One of the x squared is positive and the y squared is negative, or the y squared is positive, then the x squared is negative. And that's how you recognize that what you have is a hyperbola. So those are the 4 types of conic sections, the 4 types of shapes you can get when you draw the graph of a quadratic equation, of an equation with squares in it, with an exponent of 2 on your variable or variables. Okay, that being the case, again, there's much more we could talk about in terms of conic sections, but we're just really just touching the tip of the iceberg, so to speak, where we're just indicating, so we'll have an idea. And it's important to be able to recognize, look at an equation and recognize what type of shape you're going to have, and then to be able to do a sketch of it. Again, very simple sketches for the ellipse and the hyperbola. For the circle, you have to be able to find the center and radius. And for the parabola, you have to be able to find the vertex. And for all of them, you should be able to find the intercepts. For all four, you should be able to find the X and Y intercepts. Those are the things you have to be able to do for conic sections. Number one, let's call this A, find the intercepts for any of them. For the parabola, you have to be able to find the vertex. This is an addition. For the circle, you have to be able to find the center and the radius. And I'd like to do a little bit more work here. I will give you a couple of you look on Delta Math to see if you make sure you're current with your homeworks if you haven't, and that you've done all the quizzes. I'm not going to be giving additional homework over the Thanksgiving weekend. What I will be doing is be sending out what I called a study guide, just a list of an outline of what we covered in the course and all the important formulas. And for each one, there's examples of the type of questions you should be able to do. And there's also an answer key to it. So I'll be posting that on the information page of our Blackboard account. Okay, so today I'd like to start something new. And I know there are not a lot of people here, but we're going to start it anyhow. There are basically two more topics that we have to cover. One topic is called trigonometry, and one topic is exponential and logarithmic equations and concepts. So today we're going to one of those chapters are in the book and one of them is not. The chapter on trigonometry is not in the book. There's not very much you have to know about trigonometry, but it's all going to be taught in class. And again, it's going to be all the important information that you need is on the study guide. I could send you out a chapter from a different book or something made up, but it covers much more material than that's necessary for us. So I think I prefer just doing it in class. And again, you can always review it on the watching the videos, the YouTubes. Okay, what is trigonometry? Until now, basically, the topic that we've been covering in this course has been algebra. Algebra is the study of numbers. And basically, when I deal with things like X's and Y's, I'm basically, those X's and Y's that I'm dealing with are numbers that we don't know what the value of, but the variables are used as representatives of numbers. So algebra is a study of numbers and all the things you could do with numbers. We also did a little bit of geometry. Geometry is the study of shapes. Where did we talk about shapes? When we did graphing. We graphed lines. A line is a shape. We graph points. A point is a shape. We graph circles and ellipses. Those are all shapes. So those all belong to the subject of geometry. Those are two branches of mathematics. There are other branches. One of the branches is something called trigonometry. There's something called calculus. These are all different topics of mathematics. So what do we study when we're studying trigonometry? Well, the name is giving us a little bit of a hint. The prefix tri means 3. And metry, or no metry, means something about numbers or measurements. Metry, like the meters measurements. So it has something to do with 3, and it has something to do with measurements. And what you're really studying is triangles, which are 3-sided figures, and the measurements of parts of a triangle. And specifically, the type of trigonometry we're going to be doing is something called right triangle trigonometry. So what is a right triangle? Well, a triangle, you know, is a 3-sided figure. It's really this only if you have, you can't make a closed in shape with just 2 sides or 1 side. So the least number of sides you can use to enclose a straight-sided figure is 3. So that's a triangle. And really every other straight-sided figure, let's say you have something that looks like this, which is something, by the way, called a pentagon, because it has 1, 2, 3, 4, 5 sides. It doesn't matter. If you started drawing what we call our diagonals, you would see that you could break up your figure into a number of different triangles. So really, if you think about it, a triangle is the building block of all the different, as I say, straight-sided, and I'm not talking about curved things like circles, I'm talking about straight-sided figures. Let's say we talked about earlier in the term about a rectangle. We talked about finding its perimeter. Notice if you would draw what we call the diagonal, you'd end up with 2 triangles. So again, if we want to start at the simplest type of figure we could talk about, obviously it has to be the triangle. And that's why we spend some time in it. Now, a right triangle, I'm sure you've heard that term before, is a triangle in which one of the angles is what we call a right angle. A right angle is one that makes a L shape. If you look around your room, I'm sure you'll see plenty of places where you see right angles. Look at the corner of your door. Look at, actually, I don't think you can see the whole thing. This blackboard happens to have, it happens to be a rectangle. A rectangle has 4 right angles. A right angle has 90 degrees. So another word for right angle is a 90-degree angle. The total number of angles in any triangle, not just a right triangle, but any triangle, it always adds up to 180 degrees. A circle is 360, a complete circle. It turns out the angles in any triangle don't add to 360, they add up to 180. Which means if I know, let's say this is a right triangle, then this, and I told you that this angle is 50 degrees. If you think about it, this one will have to be 40 degrees. Why? Well, there's 2 ways of doing it. I could do 90 plus 150 and get 140. And if I subtract the 140 from 180, it gives me 40. Or I can think about it this way. The right angle, if I'm talking about a right triangle, not just any old triangle, but a right triangle, one of the angles has to be a right angle, has to be 90 degrees. So the other 2 together add up to 90. And therefore, if one is 50, the other one would have to be 40. So usually when you're dealing with a right triangle, it's easy to figure out. If you know two of the angles, it's very easy to figure out the third angle. I think you should notice. This is what we call a right angle. This is our square corner. These two angles have to each be less than 90 because the two of them together are adding up to 90. They are what we call acute angles. An acute angle is less than 90 degrees. So in any right triangle, you're going to have one right angle, 190-degree angle, and two other angles that are each less than 90 degrees. They're going to be acute angles, and they're therefore the whole, and all three of the angles will always add up to 180. Okay, now, one of the things that we want to do is learn how to call any triangle by its letters. We're going to specifically talk about right triangles because they're the ones that we're most interested in. So let's again draw ourselves a right triangle. Usually we use three letters to call by the name of a triangle. We put three, and they're capital letters, at what we call the vertices, the corners of the triangle. I can call this one A, this one B, this one C. I could call it D, E, F if I wanted to. Usually, if we're using A, B, and C, we usually put the C at the right angle. In other words, the two, A and the B, and this is called, this is a symbol you use. This is a symbol for a angle. It looks like a little angle with, I don't want to just write it with a. In the book, you might see it just like that, but I try to put that other line across it so that it doesn't look like an L. I can talk about angle A. I can talk about angle B. I can talk about angle C. And the triangle itself, and what this is the symbol we use for triangle, is called triangle A, B, C. In other words, to name a triangle, you're going to use all three letters. I could have also called this triangle CBA or CAB or BAC, or in other words, it doesn't matter what order you put the letters, as long as you call all three letters. Now, obviously, a triangle, triangle, three angles, you have three angles. But not only do you have three angles, you also have three sides. As I said, usually the angles we call by a single letter. Sometimes if it gets more complicated, we use more letters, but for the simple cases, we just use a single letter for an angle. But what do we use for a side? Let's say I wanted to talk about, there are three sides in this triangle. There's the one that goes from C to A, there's the one that goes from C to B, and there's the one that goes from A to B. The way so sometimes to call the sides, we are going to have to use two letters. I could write something like this, CA, and I put a little line over it to show you that it means side CA. Now that means that we're talking about the line segment, the piece of the line that starts at C and goes to A. I could have equivalently called it a C, because it doesn't matter if you go from C to A or from A to C, it's the same line. This one would be called BC or CB. This would be called AB or BA. Now, as soon as you start using two letters, then you have to start searching for things. Much easier, let's say, with the angles. If I say, look for angle B, there's only one place to look, because you look where the B is. So using a single letter is more efficient, easier to work with than two letters. But obviously I can't say, look at side capital C, because capital C represents the vertex, the point here, and it's not a side, it's just a point. So what we sometimes do, and this is a universal thing that all textbooks will do this, we've used capital letters to name the angles. We'll use lowercase letters for the sides. And how do we do that? Well, I don't see any lowercase letters in here, so I have to put in the lowercase letters. And it's done in a very specific way. If I look, let's say, take side BC. Now, side BC is directly across from what we call opposite angle A. We're going to call this small a. In other words, we label the lowercase letter based on the angle that it's across from. So if I look at this side, I know it's BA, but it happens to be right across from capital C. I'm going to make this one bigger. The problem is with the C's that the big capital C and the lowercase c are just, they look exactly the same except for the size. So this would be lowercase c because it's opposite angle C. And this side is opposite or directly across from side B, angle B, so this is going to be called lowercase b. So we'll then have our three angles, and now we'll have our three sides, small a, small b, and small c. And it's just easier when you're looking at a picture to focus in on a particular side or angle if all you have to do is look for one letter. Okay. Now, even before we actually go to trigonometry, there's an important formula that you have to learn that applies to right triangles. What is that formula? That formula is called the Pythagorean Theorem. Called the theorem, but basically it's just a formula. And the formula goes like this: a squared plus b squared equals c squared. In a right triangle, which is what we're discussing here, if you take the a and you square it and add it to the b after you square it, you'll get the c squared. I'm going to demonstrate this with specific numbers in a second. It always turns out in a right triangle that the largest side of your triangle is going to be the one that's directly across from the right angle. And that side, and if you look at it, it makes sense. This is the slanted line is bigger than either this one or this one. That side opposite the right angle is called the hypotenuse. I don't think it has any relation to the hyperbola, just starts with HY. Maybe there is, I don't know. Anyway, this side here is the hypotenuse. The other two sides are called the legs. There are two legs. There's leg A and there's leg B. So the legs are the two shorter ones, and the hypotenuse is the longer one, the one that's directly across from the right angle. Okay, so let's say I gave you an example like this. I'm taking a problem out of a final exam where we're given an example that looks like this. It said find the side of the length of side B. We want to find side B in the triangle below if A equals 10 and C equals 26. And here's the picture they gave us. And they called this A, B, and C. They didn't even put in the capital letters, they just put in the lowercase letters, which are the side. And they put in this little box in the corner. When you see this little box in a corner, it means that that's the right angle. So they want us to figure out what side B is if we know what side A is and what side C is. Well, anytime they're talking about a right triangle and they give you two sides of the right triangle, what you're going to have to use is the Pythagorean theorem, the A squared plus the B squared equals the C squared. And always remember, the C stands for the hypotenuse. If they don't put in the letters for you and they just give you a picture with numbers, you know that the C the A and the B doesn't matter. The C has to be put in first. It's the longest side, it's the side that's opposite the right angle. So if I want to solve this question, I'm going to the formula, I'm going to stick it into the formula. So I know A is 10, so this is going to be 10 squared. B I don't know, so I'm going to call that B squared. And C is 26, so I'm going to do 26 squared. And of course I need my calculator to figure this out. So first I do 10 squared. Well, that's easy. 10 squared is 10 times 10, that's 100 plus B squared. Now I could do 26 squared. And that comes out to be 676. I'm going to stop here for a minute and just tell you something very important. You must have a calculator from now on. There is no way that we're going to do the next two chapters, the last two chapters of this course without a calculator. Until now, If you had a calculator, it was helpful, but if you didn't have it, you probably could do the examples without it. But when it comes to trigonometry and the next chapter, which is exponentials and logarithms, it's essential that you have a calculator. There are many things that cannot be done unless you have a calculator. There are buttons on the calculator that will give you different things for trigonometry, different things for logarithms that you can't get access any other way. So make sure you have a calculator. Okay, going back to this problem, I'm going to subtract 100 from both sides, which will leave me b squared equals 576, which means the b has to be the square root of 576. Now, if you notice, they didn't put a plus or minus in front of it, because when we're talking about the side of a triangle, it can only be positive. So we have to do the square root of 576. Well, my calculator will do the square root of 576. Not only not always will it come out to be a perfect square, but in this case, it does come out, comes out that b is 24. So b would have to be equal to 24. This is what's called using the Pythagorean theorem. Look at how powerful this is. You only have to know two sides of the right triangle, and you can always figure out the third side. Going to give you another one to try on your own. Suppose I give you a triangle. It's a right triangle. I'm going to draw the picture. And this side is 5. And this side is 12. I want you to find the hypotenuse of this right triangle. So I want you to put in the letters, and I want you to use the Pythagorean theorem to solve this problem. While you're doing this, I'm going to take attendance, and what I'm going to do is, instead of saying who's here, I'm just going to give everybody who came today a extra credit. Because it's only fair. You made the effort. There's only really 4 of you, so you're going to get 4 extra credits here. I'm putting it down. Emma.
Good morning, I'm here.
Yeah, I see. I'm giving you extra credit for coming today.
Thank you.
Thank you. If you hadn't come, I wouldn't be teaching if you 4 hadn't come. I guess everybody's taking a little early vacation. Okay. Isis, you're here. We spoke before. Oriana, you're here. And Jenna, you're here.
I'm here. Good morning.
Yes, good morning. Okay. And certainly, if you want, you could all put your mics on, because It's not going to be disruptive. If you have anything you want to say or ask, go right ahead. It's not much of a class. More like. Okay, are we ready to do this example? So I like to always put on letters. If there are no letters there, I can assign the letters. The A and the B, it doesn't matter. I can put the A on the top or I can put the A on the bottom. What I have to do is I always put the C at the right angle. So I usually put the A here and the B here, which will make this equal to side A, remember, because it's across from angle A. This will equal side B, because it's across from angle B. And this is our small c. And when it asks us to find that third side of the triangle, what we're looking for is the hypotenuse, this third side of the triangle. And again, it's a right triangle, so I know that a squared plus b squared will equal c squared. So I'll do 5 squared plus 12 squared has to equal c squared. And 5 squared is 5 times 5, which is 25. And 12 times 12 is 144. So that'll give me 169 is c squared. So the c has to be the square root of 169. Now 169 happens to be a perfect square. You may recognize it. If not, you can apply your calculator, and the square root of 169 is going to give you 13. So the hypotenuse of this right triangle happens to be 13. Let's do one more.
I have a question.
Yeah, sure.
Wait, how did you get 13?
Did you see how I got 169?
Yeah.
Okay, so I have to take the square root of 169. Do you have a calculator?
Yeah, I do.
What's the square root of 169? You know how to do the square root?
No.
Which do you have? The TI 30X?
Yeah.
Okay. I think that, do you see a button that says X squared? It should be on the first column.
Yeah.
What is it? You see that above it, it has like a square root sign?
Yeah.
So anything that's written above means it's called what we call a second function of the key. All the keys, all those buttons do at least two things. So if you want to do what's written above, what you have to do is first press the second button, which should be right near the top. See it? You
Yeah.
see that's a second?
Mm-hmm.
Okay, so you press first that second button, and then you press this X squared button afterwards. And what happened? Did you get a square root pop up?
No. Probably I'm doing it wrong.
Do you want to show me you want to, I can look at your calculator. Let me see if I can.
Now is not a good time.
If you're opening, if you would open up your. You want to open up your video, or you can't do that?
I can't do that right now.
Okay. And we'll see if we can get a picture. I wish I had that calculator with me. I don't. You know what, instead of doing that, let's see if I can, let me go back. Let
Okay.
me see if I can. Your calculator looks basically like this with a bunch of buttons, right? I'm doing this, but everybody else could listen to this because it affects how you use a calculator. Do you have a button that says second over here?
Yes. That's on
And
top.
and you have this button over here that says x squared, right?
Yeah.
Okay. Press the second button
Second.
and then press the x squared buttons afterwards.
Mm-hmm.
Does it pop up with a square root on the
Yeah, but they don't give me no. Yes.
okay, once you see that symbol, you're going to type in 169. You're gonna just press the numbers 169.
Oh, I got it. Thank
And
you.
then press equal.
Yeah, I got it.
And then did you get the 13?
Yes, I got 13.
Okay, so it's
Thank
very
you.
important because for this, and everybody should know how to use a calculator to do these, aside from adding, subtracting, multiplying, dividing, finding square roots. And you're going to be using your calculator a lot. Okay, I'm going to do, should we do another problem now?
Yes.
Okay. Let's say I gave you a circle that looks like, a right triangle that looks like this. Let's say this is 6, and let's say this is 15. Let's see if you can find that third side of that triangle. I'm going to let you label it and see if you can figure out this side of the triangle. Are we ready to try together? Anybody one more time? Okay. So again, I'm going to label this A, B, and C. And again, this is going to be my small a. This is going to be my small b. And this is my small c. Remember that the c is the one that's the hypotenuse, the one that's across from the right angle. Okay, again, it's a right triangle. I see this little square corner. So I know my Pythagorean theorem. It's really easy to remember. ABC, basically. It's a squared plus b squared equals c squared. It's not a plus b equals c. That would be simpler, but it's a squared plus b squared equals c squared. It's called the Pythagorean theorem after a Greek mathematician called Pythagoras. He was the one who discovered this. So his name is always associated with it. So we stick in the numbers. 6 squared. The b we don't know, so we're leaving it b squared equals 15 squared. Okay, now if you want, you can do the b squared on your calculator. It's just 6 times 6, which is 36. And the 15 times 15, you do it on your calculator, is going to give you 225. So if I want to figure out what the b squared is, I'm going to have to subtract 36 from both sides. So I'm taking out my calculator, clearing what I had from there before, and I'm doing 225 minus 36, which gives me 189. So it turns out that b squared equals 189. And if I want to find out what b is, I'm going to have to do the square root of 189. Well, let's see what happens when I stick 189 in my calculator to do the square root. I get something that reads like this. You're trying it on your calculator, you're getting 13.747727. It keeps going on and on. 189 is not a perfect square. The square root of 189 is not rational. What does that mean? It gives us an unending, non-repeating decimal. Now, usually we don't like to leave that answer like that. As a matter of fact, we just did a chapter on square roots, on radicals, and what we didn't, you could eventually put something in decimal form. Usually when you're putting something in decimal form, you do rounding off. You can't put all the decimals. I mean, that would be ridiculous, and depending on your calculator, you could have 100 digits there. You can't put them all in. It's impossible because it goes on, it never ends. So you could round off. Let's say I said round to the nearest 100th. Then you would go, you'd want to end after the 4. You look at the next one is 7. So to the nearest 100th, it would be 13.75. But more likely, what we want to do is not round it, but simplify it. Remember how we simplified? We broke it up into 2 parts. Okay. What number goes evenly into 189? That's in perfect squared. I think 9. Nine times 21 is what the square root of 189 is. In other words, I was able to break this down. I didn't want to, 2 or 3 or 4 wouldn't work. Well, 4 wouldn't work because it doesn't divide evenly into it. And the next one is 9 because 5, 6, and 7 are not perfect squares. So this could be simplified to the square root of 9, which is 3 times radical 21. So what we very often, we're not going to have a perfect square. And therefore, we're going to have to just simplify a radical and give our answer that way. Okay, I was going to cover some more material today, but given that we have such a small attendance, and this is complicated, I think we're going to just leave the rest until Monday. We're going to work on our trigonometry on Monday as well. look out for the study guide. And because that's going to be a big help to you when you don't have to go through a whole book or all the different topics. You could look at the study guide and it'll give you an idea of all the different topics that we have covered. Again, there have been I've been giving for each chapter that we've done, there has been a set of examples, and I will be putting out one for the trigonometry as well. So look out for that. Okay, anybody have any questions? If not, have a happy Thanksgiving and enjoy the extra couple of days off. Rest up and try to get a little bit of a heads up, because when we come back, we only have about 2.5 weeks, and then we have our final. And we do still have to finish this chapter on trigonometry, and we have to do one other chapter. So what I'm going to be starting to do is just giving each time, instead of just only doing examples when we start the class of what we had done the previous class, I'm going to do review examples so that we can have a variety of the different topics that we've covered. And certainly if there's any topic that you would prefer me to spend a little bit more time on, you should let me know so I can spend that extra time in review. Okay, happy holiday.
You too.
Bye-bye, have a good day.
Thank you.